Hey everybody, what is happening? Well, we've covered our acids and bases. Very interesting way to say it. And right now we're going to be talking about types of chemical reactions. So all the stuff that we've been doing so far, we've been building our chemical knowledge. We've been learning about the periodic table of elements, and we've also been learning about how to balance equations and what happens. So now we're going to look at 6 different types of chemical reactions. First off, we've got synthesis, which is another word for making things. So that's things coming together. The next we've got decomposition, which is breaking things down. Next we've got a single replacement, and this is very interesting. We're going to talk a little bit about Valentine's Day chemistry here. And then we've got double replacement. Neutralization, we know all about this. We've got an acid plus a base, and then we get a salt plus water. And we write water like this in when we're doing an acid-base reaction. Next, we've got combustion, and this deals with our organic chemistry that we just covered. So we have an organic molecule, and it's usually a hydrocarbon, and we add oxygen, which is part of Hofbrinkel, and we get CO2 plus water every single time. And we also get a little bit of heat and energy. All right, so let's look at those just a little bit further. All right, so synthesis reactions. Synthesis reactions involve two simple substances coming together to form one. So we've got A plus B, and we get AB. All right, so synthesis means to make. So like a synthetic drug, something like that. We put things together to get a final product. So we've got an element plus another element, and we get a compound. So in this example, we've got sodium plus chlorine, and we get NaCl. Next, we've got nitrogen and oxygen, and then we get dinitrogen oxide. All right. Next, we've got decomposition, and this is breakdown. So what we start with, and you'll be able to notice this when we look at this, is we start with something large. We start with a molecule, and we get its elements. All right. So we start with AB, and we break it down into A plus B. All right. So decomposition reactions involve breaking a compound down into smaller substances or simpler substances. The simpler substances may be smaller compounds or even single elements. So let's check this one out. We've got NaClO3, and we get NaCl plus O2. Next, we've got single replacement. Now, this is our Valentine's Day chemistry. So in a single replacement reaction, a reactive element, a metal or nonmetal, and a compound react to produce another element and a compound. This means that one of the elements in the compound is replaced by another. All right. So let's we got a cute couple here, and so we've got the girl, and we've got the boy, and we've got another boy right here. Well, if we single replace this, well, it looks like, we had a little bit of a switcheroo, and we've got this guy on the outs. Or the blue and the red were initially together, and the black came over and said, hey, come on over here. And then the red came over and said, sure, that sounds good. And then the little blue guy was left all on its own. So really, if we have this, we've got AB plus C, and then a single replacement. So we're going to replace either the metal or the non-metal, and you'll notice that Cu and Mg are both metals, so they're going to switch, and we get C plus B plus, or C and B plus A, and A is left on all on its own. Mg is a metal, so the metal in the compound. Cu is the one that gets replaced. Now, you'll notice that because Cu and Mg were both metals, they're the one that replace each other. And if we look at this example down here, we've got fluorine plus sodium iodide. And you'll notice that because we have a non-metal and a non-metal, they're the ones that are going to switch. So we get our new product of NaF, or sodium fluoride, and we're left with I on itself. And you'll notice that this is part of Hofbrinkel and F is also part of Hofbrinkel. So that's a single replacement. One of them gets replaced. Next, we've got double replacement. So this involves a reaction that has two compounds switching their ions with each other. We often get a precipitate, which is a solid. And we're going to be looking at this next week. So we're going to be looking at all different types of these reactions. So we've got lead nitrate plus sodium iodide, and we get sodium nitrate plus lead iodide. All right, so what we have here is we've got AB plus CD. And what you're going to see is that the metals are going to swap. And so what we get is we get CB plus AD. All right, and you'll notice that the metals, all we have to do is think about the metals swapping. It's much easier if we just focus on the metals, and they're just going to get a new partner. So again, we've got calcium chloride plus sodium carbonate, and then we've got calcium carbonate plus sodium chloride. And so what we're going to do is look at how my metals swapped, all right? And they got a new partner. They swapped. So you can basically, they're just going to swap, and we'll notice that we've got two compounds together to be having a double replacement reaction. Next, we've got a neutralization reaction, and we know this one. And so we've got an acid plus a base, and we get water and a salt. And we always, or I like to always, write my water like this because it's a lot easier to balance. All right? And we spent a lot of time on that one. I'm gonna skip over it quickly. And then finally, we've got a combustion reaction. Now, combustion, I want you to think about burning gas. All right? Burning gas or coal, anything that we need to light on fire. So a combustion reaction is a burning reaction, all right? A substance reacts with oxygen to produce heat. Now, if you think about having a campfire, it's got to have oxygen. So if you blow on it, the fire gets bigger. So carbon dioxide and water are always the products of a combustion reaction. So, and that's how you can tell that it's a combustion reaction, right? So right now we've got CH4, which is a methane, and we usually get where we have an organic molecule plus oxygen, and we always get CO2 plus water. Now, when we're balancing combustion reactions, we always do the C's first, we do the H's second, and then we always do our O's last. And we always do our O's last because sometimes we get a number that like a fraction, and then we need to multiply the whole thing by 2. And you'll see an example like that. All right. So I'd like you to read over those. Let's check out the last page here. And we can identify the following. So I'd like you to try to identify these reactions. And then we're just going to go through and we're going to do a couple of the reactions here. All right. So I'd like you to try the top bit, and we'll leave this for class. All right, have a good rest of the day, you guys.